Hello, computer science students. In this video series, we're going to talk about interfaces, and specifically two things. One is the comparable interface that lets us sort things, and two is how we create our own interfaces. So the first couple of videos here, we'll talk about the comparable interface. This is an interface that somebody else has created, and we're going to use. And so it'll be our first example about what an interface is and what it lets us do. And then we'll talk about how to actually write it and implement it. So to start, the comparable interface is used so that we can sort things. Imagine you make a class, maybe like the student class we've seen in prior examples. So we're representing a student at Elon, and maybe we have an ID number, maybe we have a last name, maybe we have a first name, and we put a bunch of students in an array list. So we make a bunch of students, we put them in an array list, and we want to sort them. Maybe we want to print them out by last name, maybe we want to print them out by first name, maybe we want to sort them by ID. However we want to sort them, we can determine that or indicate that by implementing the comparable interface and identifying one of these things as the value to sort by. And so that's what the comparable interface allows us to do. It allows us to choose how things will be sorted, and therefore allows us to sort students. And so sorting is an important concept in computer science. You do it a lot. It's valuable. And so I'm gonna start with a really basic sorting algorithm here. I'm gonna start with a basic list, basic sorting algorithm, and we're gonna use this to show why the comparable interface only needs certain information. And basically what information you're providing when you implement the comparable interface. So let's start with just talking about sorting algorithms. So let's put a marker, I'll use a star at the end of our list. If we want to sort this list, and let's say in this case we want to sort it from lowest number to highest number, so ascending order, then what we need to do is find the largest item in the list, we'll call it X, and move it to the right of the marker, and then find the largest remaining number and move it to the right of marker and repeat. So what does this look like? Well, if we identify the largest number as 8 and move it to the right of the marker, we end up with a list of 6, 2, 1, star, 8. Okay, so that step's done. Now we find the largest remaining number, 6, and move it to the right of the marker. That gives us a list of 2, 1, 6, 8. Oh, and I forgot my star here, so we still have our marker. Largest item to the left of the marker is 2. Move 2 directly to the right of the marker, and we end up with 1, star, 2, 6, and 8. And then one final step, I should have left myself more space or written smaller, but we would take the largest remaining number, which is 1, move it to the right of the marker, and then we'd be done. So the marker is at the start of the list. We have 1, 2, 6, and 8. Okay, so it was a little bit messy, but hopefully you see that following this process, finding the largest number, moving it to the end, repeating, allows us to sort a list. The same sorting process could work from largest to smallest if instead of finding the largest number, we found the smallest number and moved it to the right. Smallest number, move it to the right. Smallest number, move it to the right. And then our list would be sorted in reverse order, 8, 6, 2, 1. You could do alphabetical. Which one's last alphabetically, put at the end. If we had strings, which one's first alphabetically, move it to the end. Right, so as long as this one step, M2, is set up correctly, this process will work, right? So M1 is sort of a basic step. It doesn't matter what's in the list. You just put a marker down. Doesn't matter what's in the list. Step 2, we need to know what's in the list. It matters. It's important. The thing that we're sorting needs to be done here. Step 3, assuming we've identified a thing to move, step 3 is just moving a thing to the end of the list. And step 4 is just a repeat step. So of all 4 of these steps, only one cares what's in the list, and therefore changing this one can change how your list sorts. And so this step M2, for any sorting algorithm is the only one that cares or knows what's in the list and chooses how the list is sorted. So that's the important step. So we're going to dive a little deeper. So let's turn this, let's make this look a little darker, make this look a little darker, And let's flesh out an algorithm that would allow us to complete step M2, finding the largest item in the list. So to complete step M2, I'm going to give you another algorithm. And this algorithm is, how do I find the largest number in a list? So let's go back to our 6, 2, 8, 1 list. Okay, so let's say that this whole thing is called list L. All right, so we're going to identify the first item in list L, and we're going to give it a variable, or store it in a variable. Let's call that variable I. All right, we're going to compare that variable to the next item in the list, which we're going to call variable N. So N being next. So if variable N should appear after variable I in the sorted version of our list, then we're going to label or identify N as I. We're going to switch that I label. Now in this case, we're going ascending. So 1, 2, 6, and 8 should be the end result. So 2 should not come after 6, right? 6 is larger than 2, so this is not true. N should not appear after I. So we do not identify N as I. Okay. Instead, Instead, there we go. Instead, we're going to repeat. So we're going to compare I to the next N. The next N would be 8. Should 8 appear after 6? Yes. So we're going to replace that, label 8 as I. That which means we no longer have 6 labeled as anything. Okay. So now we compare I to the next N. We keep moving through the list, right? N was at 2, now it's at 8, now it's at 1. Should 1 appear after 8? Well, no. Right? 8 should appear at the end. So now at the end of this process, the variable labeled I is our max. Whoa, that's the wrong symbol. The variable labeled I is our max. So we've completed step 2, find the largest item, the max item in our list. So that worked. And then, if we follow this process, what would happen is we would move the 8 to the end of our list, remove it from consideration, and then we would have the rest of our list, 6, 2, 1, and we'd repeat this step M2 again. So we start off with 6 as I, compare it to the next variable N. Should 2 come after 6? The answer to that is no. So we leave I pointing to 6. Should 1, oops, we'll keep going. Should 1 appear after 6? And the answer to that is no. So we're going to cross that out. And so we end up with an I that's 6, and that tells us to move 6 to the end next, right? And you'll see that this would work as well for 2, and then with 1 left, it just starts as I, and we would move it to the end. So this step of identifying the largest, this algorithm works. So let's examine again. Which of these steps cares what's in the list? Identify the first item in the list as I, doesn't matter what the values are. This step does. Compare I to the next N. But assuming we can do this comparison and we can tell which one should appear, then just changing a variable name and N and I, again, that doesn't rely on what's in the list. Step F4 is just a repeat, and step 5 is done. So the only step that actually cares what's in our list is one little piece. Again, this one piece of compare I. So compare one item to the next item in the list. So as long as you can compare one item to another, you can build the rest of the algorithm with just moving stuff around to be able to sort any list however you want. So this one step is compare. And so the interface comparable allows you to, when you create a class, decide how will I compare one item in my class to the next. And so assuming you provide that definition, then you can sort. And so that is why the comparable interface is so useful. And that's why when we, as we'll see in the next video, when we implement the comparable interface, when we create definitions, all we're doing is saying, how do I compare one item in my list to the next? How do I say which one goes after the other? So when we jump in our next video, We'll talk about how we actually write that method, how we actually determine this value. But hopefully I've convinced you at least that all you need to do to sort any list of items is figure out how to compare one item to one other item of the same type. So we'll jump into the next video, and I will see you guys next time.